Good morning. So myself, Dr. Maheswara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics, and today's topic is inclined surfaces. So that means hydrostatic forces on inclined surfaces, submerged surfaces. So before going to the topic, the course outcomes. The course outcome means after completion of the course, the student will be able to solve something or understand something. So those are called course outcomes. And under this, course outcome 1 is after completion of this, course outcome 1 is the students will be able to define the fluids. So what is the fluid and what are their properties and what is the surface tension, all those things they will understand. And course outcome 2 is the Newton's law of viscosity. So that means the classification of fluids based on the Newton's law of viscosity. So what are the Newtonian fluids, what are the non-Newtonian fluids, and some problems on the viscosity. So this classification of fluids based on the Newton's law of viscosity is under the course outcome 2. And course outcome 3. So it is capillary rise or fall. So what is the capillary rise or fall means? Whenever you are inserting a small diameter pipe or tube into a fluid, so that fluid will rise into that small diameter pipe tube, so which is called the capillary rise. And some of the fluids will not rise, they will fall compared to the top surface of that fluid. That is called capillary fall. So that will come under the course outcome 3. So then course outcome 4 is the surface tension. So any fluid at its outer surface, it will have some tension. Okay, so which is nothing but called surface tension. And what are their applications? Those knowledge will be in the course outcome 4. Course outcome 5. So it is the compressibility. So that means if an application of external forces, if there is a volume change, then that is called a compressibility. So gases will change their volume after application of the external forces. So whereas water will not, liquids will not change their volume. So whenever the fluids are changing their volume, they are called compressible fluids. So like gases and water and liquids, so they will not change in volume after application of the external forces. So that is called the incompressible fluids. So compressible fluids is a gas, incompressible fluids is a water. So that is the course outcome 5. Then course outcome 6 is the pipe flow or fluid friction or energy losses. So whenever a fluid is allowed to flow through the pipe, so there will be two surfaces, fluid surface and pipe inner surface. So while traveling, it touches the inner surface. So it will have frictional forces. So that's why energy will be lost. So if a fluid is traveling from one point to another point, because of the frictional forces, there will be loss in the head. So or loss in the energy. So that pipe flow or fluid friction or fluid pressure. So this will come under the course outcome 6. So today's topic is hydrostatic pressure and forces on the inclined surface. So hydrostatic pressure means what? So hydro means is water, static means no movement. That means if a water is having no movement, so still at rest condition, those are called hydrostatic. So pressure and force. So how much pressure will be acted because of that rest static fluid, or how much force is acted on the any submerged object. So the thing is that the water is not moving. So hydrostatic, it is in static condition. So here surfaces, inclined surface. This topic will be related to the inclined surface. So the inclined surface means surface is nothing but a sheet. You can take it as a sheet which is having length or width or height or width. So these surfaces, if you submerge into a fluid, so there are three types are there. So one is the surface can be in horizontal position, or surface can be in vertical condition or status, or surface also possibly at an inclination of theta degrees. Okay, so these are three different conditions of the submerged surfaces. So one is submerged surface is horizontal, another one is submerged surface is vertical, and submerged surface is inclined. Okay, now if you see the definition for the pressure on inclined surfaces. Okay, see what is the definition is given here, refers to the pressure exerted by a fluid at equilibrium on surface that is tilted relative to the vertical. So the definition is very same for all the surfaces. So if it is horizontal, if it is inclined, if it is vertical, the definition is same. Okay, hydrostatic pressure on, here instead of horizontal surface, we will replace that with the inclined surface or vertical surface. So hydrostatic pressure on inclined surface refers to a pressure exerted by fluid. So that means fluid will exert some pressure on any submerged body. So because it is an inclined surface, the definition is telling that the fluid is exerted a pressure, or pressure exerted by a fluid onto the inclined surface at equilibrium condition. Okay, so this inclination is relative to the vertical. So vertical, with vertical, how much angle it is tilted. Okay, the pressure distribution varies with the depth. So here also for any submerged surfaces, the pressure varies with the depth. That means as you go deeper and deeper into the fluids, so pressure will be increasing. So that is a linearly proportional. So when you go deeper, the pressure will get more. So more depth, more pressure. And also not only that, more depth and more pressure relation, but also with the inclination of the surface. So what will happen if the inclined surface, if more inclination, less inclination, vertical condition. So that also related to the how much force is acting on the submerged surface. Now if you see the formula, P is equal to rho GH. Okay, so here rho is the density of a fluid, and P is the hydrostatic pressure, and G is the acceleration due to gravity, H is the depth below the fluid surface. So this is formula for normal pressure on a submerged surface. And if you see the example, for a water is having density. So density means what? Weight by volume. That means for 1 cubic meter of volume, if you pour the water in that box, it weighs 1 ton. That means 1000 kgs, which is called here density. So here water density is a constant, which is 1000 kg per meter cube. If it is not given specific density in the problem, we can take 1000 kg per meter cube as a constant. But if it is specifically given in the problem, we have to use that particular value. And the depth is given here 5 meters. That means the surface water is here, and its rho is given 1000. And here object is here at the depth of 5 meters. So then what is the pressure exerted on that at a depth of 5 meters? So it is nothing but the rho GH. So rho is the density of water is 1000, and acceleration due to gravity is 9.81, and 5 is the depth at which pressure is to be calculated. If you see the definition of the hydrostatic force, so initially we discussed the hydrostatic pressure on an inclined surface. Okay, now it is a force. So what is the hydrostatic force? Here also same thing. Hydrostatic, that means water at a static condition. How much force is acting on an inclined surface? That is the heading here. The hydrostatic force on an inclined surface, the total force exerted by a fluid on the surface. So that means here normally the pressure is acting different points, but the resultant force will act at certain point only. So which is called here hydrostatic force here. Okay, the hydrostatic force on inclined surface is the total force. It is nothing but the total force exerted by fluid on the surface considering the pressure distribution. Pressure is calculated by integrating the pressure distribution over an inclined surface. So you can see the formula here. F is equal to force is equal to integral P dA. So for inclined surface, this requires to determine the pressure distribution across the surface, integrating over its area, as we know this. So the force is formula is here. P is equal to half rho g h square B into cos theta. Okay, so half rho g h square B into cos theta, where h is the vertical height of the surface. So h is the vertical height of the surface. So B is the width of the surface. Theta is the angle of inclination in radians from the vertical. So if it is vertical, then this is the vertical. This line is the vertical. So this is the theta angle, that is in terms of radians. So that means here the angle can be measured in terms of degrees, radians and gradients, but we have to apply here in the radians. So the angle degrees should be converted into radians by multiplying the pi by 180. So this is the force formula of rho g h square B into cos theta. So if you see the example, for an inclined rectangular surface, height 4. So the height of this inclined surface is given 4 meters and width is given 3 meters. So this is 3 meter, this is 4 meter. Inclination is equal to theta, is 30 degrees. So this is the 30 degrees. So then we are having the formula cos theta. So cos theta is equal to cos 30 is equal to 0.866. So if you apply the numbers as per this formula, F is equal to force is equal to half into rho is 1000 kg per meter cube, G is acceleration due to gravity, 9.81 meter per second square, or H is the height, surface height, which is given in the problem is 4 meters, so 4 square into width of that surface is 3 meters, and cos 30 is 0.866. So if you multiply this, you will get the force value. So this is 2,26,500 newtons. So that much. That means it is roughly how much it will become 226,500. So if you remove this, then it will become kgs. So 22.65 tons of force will be acting onto the particular surface. And another one is here, center of pressure. So center of pressure is different and centroid is the surface is different. Okay. So if the centroid will be, this is the centroid, but the center of pressure means total force of fluid will be acted not at the centroid of the surface, it's somewhere below that centroid of the surface. So that is the center of pressure on the inclined surface. So what is given here? The center of pressure of inclined surface is the point where the resultant hydrostatic force acts. So what is the meaning of center of pressure? Where the total force, total hydrostatic force or resultant hydrostatic force, where it is acting, that point is called center of pressure point. Okay. So it is calculated differently compared to this vertical surface. The formula is here, HCP. HCP is equal to height of center of pressure, that is equal to Ig plus H bar by AH, where HCP is the depth of center of pressure from the fluid surface. If it is a fluid surface, then this is the HCP. So that means HCP is the point from the surface to the where the resultant force of fluid is acting. So that vertical height is called HCP, and Ig is the moment of inertia about the centroid here, about the centroid, or second moment of area it is also called. And A is the, because A is also there, Ig plus AH square, AH bar square by AH bar. That is, A is equal to area of the surface, H bar is the depth of centroid of the surface. So that means centroid depth. So centroid depth, center of pressure depth. So those are the differences of H bar and HCP, center of pressure. The formula, if you readjust the formula, then the formula is becoming somewhat easier. So it is becoming HCP is equal to HC plus Ig by HC. That means HCP is equal to depth of center of pressure from the surface is equal to centroid depth plus moment of inertia about the centroid of the surface and the area into centroid distance. So then you will get the HCP, that means depth of center of pressure. So, okay. So where HC the depth of centroid of the inclined surface of the fluid surface from the fluid surface. So HC is the depth of centroid, that means if any object is here, this is the centroid depth from here to here, it is HC. Then if you see small problem here, so it is inclined surface, that means water surface is here, it is having a inclined surface. The width of this one is 3 meter and depth H is equal to 4 meter. It is given here. So HC, so depth of centroid, HC is equal to H cos theta by 2. So then you will get HC is equal to, H is 4 meter, okay, cos theta means 0.86 by 2. So there you are getting 1.732 is the centroid depth. So this is the centroid depth which is called here HC equal to 1.732. Okay, so the angle is 30 degrees here. So then Ig, moment of inertia about the centroid, the formula is BH cube by 12. Okay, and HCP means what? It is a depth of center of pressure, not the centroid, it is a center of pressure, is equal to depth of centroid HC plus Ig by AHC. So HC you already calculated. Depth of centroid. So depth of centroid is how much? H cos theta by 2, which is got here 1.732. Then Ig, moment of inertia. So BH cube by 12. B is 3, H is 4 by 12. So this is the Ig here, moment of inertia about the centroid. And area how much? This is 3 meter by 4 meter, so 12. So BH cube by area, and again HC and centroid distance. Then HCP is equal to 1.732. This is 48. Okay, 20.40. Then you will get this 3.87. What does it mean? The depth of centroid is 1.7, but whereas the depth of center of pressure is 3.87. That much depth it is there. So practical conditions. So practical considerations you will see here. Inclination angle. So the angle of inclination affects both the pressure distribution and resultant force. So if the surface is slightly inclined, medium inclined, more inclination. So this is theta, this is theta, this is theta. So the pressure distribution as well as the force, resultant force depends upon the inclination angle here. Another one is the surface shape. So here we have regular shapes and irregular shapes. Regular shapes will have formulas, just like a circular shape, pi r square, and this rectangular shape, length into width, like that. So whereas irregular shapes, we have to use the integration methods. Okay, integration methods, so that we get the those values of areas, etc. So then a structural impact. So proper consideration of hydrostatic force is crucial. So if you not calculated properly, then the failure of design failure will occur. So okay, crucial in the design and stability of structures such as inclined retaining walls or sloped surfaces. So any retaining means what here? If it is not allowing to flow, which is called retain. So there can be soil. If the soil is there, then one wall is there, so soil will not move. So if same place water is there, so some obstruction is constructed, okay, it will not move. So that is called, it is a retain. So wall which retains anything, that is called a retaining wall here. Okay, it is a inclined retaining wall. So here is what, not vertical retaining wall, it is a inclined retaining wall. So or sloped surface. So then how much force is acting? We have to correctly calculate so that it will not fail. Applications. Where will we place this? Inclined surfaces or hydrostatic pressures or forces on inclined surface. See here, sloped dams. So dam means what? If you, any two hills are there, then if you put a construction between the two hills, then water will stay here. So that is called a dam here. So dam can be normally trapezoidal shape like this. So some dams can be like this also. So sloped dams. Okay, that means here is a slope. So then the calculate the force on a sloped surface dam due to water pressure. So here we have to calculate the how much force is acted by the fluid onto the sloped surface of the dam here. Okay, that is one application. So inclined tanks also there. So assessing the forces on walls, inclined storage tanks. So these tanks. So normally vertical rectangular tanks or inclined tanks. So like this also tank can be there. So if this surface is inclined of the tanks, okay, so inclined walls of the tank, then how much force you have to calculate it on that inclined wall of the tank. Then silt barriers. So designing barriers with inclined surfaces can manage the sedimentation and water flow here. So what we did today, we will review once. So initially the definition is given for the hydrostatic pressure on an inclined surface. It is nothing but the pressure exerted by a fluid on a inclined surface at equilibrium. So when the surface is tilted relative to the vertical surface, okay, the pressure distribution varies with the depth of that point and also with the inclination of the surface. And formula for the pressure is equal to rho GH, rho is equal to density of fluid, pressure, the hydrostatic pressure is equal to acceleration due to gravity, h is the depth below the fluid surface. So if you take a small example, so where the density of the fluid, water is 1000 kg per meter cube, you want to know the pressure at a depth of 5 meters below the water surface. So rho GH is the, rho is 1000, G is the acceleration due to gravity 9.81, and depth is here 5 meters. Then we will calculate we will get the pressure in terms of pascals here. So hydrostatic force on inclined surfaces. So previously we dealt with the pressure on inclined surface. Now it is the force on inclined surface. So it is nothing but the total force exerted by a fluid on a particular point. So not the total pressure distribution. It is a total amount of pressure. Force is acting at single point. So that is the center of pressure here. So and the formula is F is equal to integral PD. If you get this, F is equal to half rho G H square small b into cos theta. So where rho is equal to density of the fluid, G is the acceleration due to gravity, and capital H is the height of the surface, and B is the width of the surface, theta is the angle of the inclined surface with the vertical in radians. So this is the F is equal to half rho G H square b into cos theta. So example is given. The sheet surface height is 4 meters, surface width is inclined surface height is 4 meters and width is 3 meters and angle is 30 degrees. Then we will get the force exerted by a fluid onto the inclined surface is half rho GH square b into cos theta. So we will get the tens of newtons here. So rho is 1000, acceleration due to 9.81, h is 4 and width is b, and cos theta is 0.866 here. So it will become 22 tons of the force exerted by the fluid onto the inclined surface of these conditions. Center of pressure. Center of pressure is nothing but where the total resultant force is acting. That point is called center of pressure. So it is nothing but the point at which the resultant force is acting from the surface of the liquid. So liquid surface to centroid of the surface is centroidal distance. Center of pressure means nothing but the resultant force acting at that particular point, which is measured from the surface of the liquid. So here SCP is the depth of center of pressure from the fluid surface. Ig is the moment of inertia about the centroid in meter per 4, or it is also called second moment of area. So an A is equal to area of surface in meter square. That means inclined surface area. H bar is the centroidal distance, which is in meters. So adjusted formulas, depth of center of pressure is equal to Hc plus Ig by AHc. That means centroid distance plus moment of inertia by area into centroid distance. So then if you see there's some small formula here, the inclined surface is 4 meters as previously, and width of this inclined surface is 3 meters, and theta is 30 degrees. Then depth of centroid is h cos theta by 2, which is equal to 1.732, and moment of inertia is equal to bh cube by 12. That means h is 4 and b is 3 meters, so bh cube by 12, and hc is 1.732. Area is 3 by 4, 4 meters height, 3 meters width, so 3 into 4, you will get the 12 meters square, and hc is 1.732. So if you calculate this, depth of center of pressure is 3.87 meters. And practical conditions, inclination of angle. So the pressure not only depends on the depth at which it is there, okay, it also depends on the inclination of the surface. So and also surface shape. So if it is a regular shape, irregular shape, we have to use a normal general formula or integration methods depending upon the surface shape here. So structural impact. So proper calculations of the forces are not calculated, then there will be a problem with the design. So design and stability of structures will be affected if it is not properly calculated. On the inclined surface of the retaining walls are sloped surfaces. And applications, if you see, sloped dams will be there. So normally dams will be in the trapezoidal form. One face is vertical here, another face is inclined. So some dams will have both sides slopes. So then it will come under the inclined surface. So such dams, sloped dams, so we have to calculate it carefully what is the total resultant force is acting onto the particular sloped surface. Or inclined tanks also. So water tanks, overhead tanks or underground tanks, if it is an inclined storage tanks are there, then also we have to use these formulas. The silt barriers. So design barriers at the inclined surfaces, okay, to manage the sedimentation and water flow. So those conditions also we can utilize this formula. Some references, if you see, K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McGraw-Hill, 2012. Another one is Modi P.N. and S.M. Seth, Hydraulics and Hydraulic Mechanics, Standard Book Course, 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.